Uh, in the current world of energy crisis and resources depletion, a completely new approach to Lignin utilization must be developed outside the classical thermal chemical frame. One of the most promising routes is to apply nanoscale lignin powder to photochemical reactions and precisely controlled temperature and wavelength conditions. Beginning as a heterogeneous atmosphere polymer with a three-dimensional cross-linked network of phenylpropane units is extremely resistant to ordinary solvents and thermal degradation. However, when converted into an ultra-fine powder in the sub-micron or nano-size range, its specific surface area increases dramatically and the probability of photon absorption as the solid liquid or solid gas interface becomes much higher than in the bulk state. By combining this high surface lignin powder with a controlled light source, for example, ultraviolet visible continuous lamps, monochromatic LEDs, or pulsed laser, and turning the wavelength intensity and spectrum to match the electrical transitions of lignins chromophores phenolic units, conjugated double bond carbonyl groups. It became possible to drive direct photolytic cleavage of the beta 2 oxy 2,4 alpha to oxy 2,4 and 5 to 5 dash linkage that dominated the lignin backbone. Simultaneously and carefully regulated temperature control. Temperature control. Thermal energy can be used to support dissociation of weak hydrogen bonds and losing the micromolecular network while avoiding excessive carbonization or char formation. In this way, the combined photothermal pathway allows lignin to be transformed from a high molecular interactable waste into a mixture of low molecular phenolic compounds, soluble oligomers, and even gaseous fragments that can serve as feedstocks for biofuels, aromatic chemicals, or carbon materials. Because this concept shifts the reaction system from a traditional purely thermal catalytic regime to a photonic surface reaction regime. It is essential to build dedicated experimental pilot plants that are designed specifically for Lignin photochemistry. Such a plant should include a powder dispersion unit, dry milling, jet milling, or supercritical carbon oxide, double oxide, CO2, carbon oxide, double oxide, assisted pulverization. Fluidized or surely circulating reactor irradiated by tunable wavelength light. A, a temperature programmed heating and cooling loop. An online spectroscopic monitoring system, ultraviolet 2 with FTIR, FT infrared ramen for real-time tracking of bond cleavage and downstream separation module, membrane filtration, solvent extraction, distillation. From this new reaction system, it is possible to map the system evolution across different parameter space, wavelengths, temperature, residence time, solvent polarity, and powder size. Once enough experimental data are collected, a mathematical plant model can be constructed, allowing the reactor to be scaled up from laboratory scale to a full-scale Lignin photochemical refinery. Even though the exact optical wavelengths and ideal operating conditions are still unknown today, the mere fact that lignin can be treated as a photoactive high-surface polymer instead of a simple black hole opens a completely new research field at the interface of pulp and paper chemistry, polymer science, photochemistry, energy materials, and chemical engineering. Therefore, the direction proposed here is not just interesting, it is a necessary evolution for an resource-starved country that has only water, air, and lignin. Japan country that has only water, air, and lignin. And for someone with an applied chemistry background, the challenge of building this lignin photochemical system from the ground up is exactly the kind of problem that deserves full attention. And plus, if we can draw and analyze the phase system diagram, many data such as the lifetime of the product, purification time, and other properties will be collected automatically. Then, by using statistical modeling to interpolate and extrapolate the missing points, it became possible to design a real experimental Lignin refinery plant. Ha 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 ha. This end. Japan is no product Japan has no products um, air and water and lignin. Three products is real Japan's form. I have I have lignin black oil is black oil. Considering lignin used to why why lignin used hmm, Japan's Japan's future is great or pure. Hmm. Bye bye.